In this video, now we need to define another way force and moments which is acting due to the gravity. So due to gravity there are forces and moments, and the equation is defined as, so this is how the equations are defined. Here the density is rho naught, and then exponential model is selected for the atmosphere. Now how this exponential model works, how this altitude works, this we need to define on top of this relationship, because atmospheric model is very important. As the altitude increases for the vehicle, the density decreases, and most acceptable version of model is exponential model for the lower altitude, such as like up to 11 kilometers, and we are not going more than 500 meters, so it is very much acceptable. So number of variables such as h, altitude, rho naught, this we need to define first, then only the density will be estimated or calculated. So we are defining it as, so this is how we are defining it. Rho naught is basically initial value of the density at sea level. So sea level density is around 1.225 kilogram per meter cube, and h is the scale factor which is important to use for scaling this model, or basically a constant which is helpful to estimate the density at certain altitude. Now we also need to define the altitude. How we will estimate the altitude? Altitude is basically coming out from the another three state variables which is not mentioned over here. So I am directly accessing from the airship, so it is in the like 12th position basically. So x, y and z, that is the z is required for us, which is our altitude. And since z is positive towards down, so altitude will be negative, so that is why this negative sign is here. So overall altitude is estimated. Now this altitude will go to this exponential model and then estimate the density which is required for our estimating of forces due to gravity. Now these forces due to gravity, they are estimated using the reference paper and their equations of motion. So now acceleration due to gravity and forces and movement and due to gravity are estimated in this way.